Hello everyone, let's start with the series Roadmap to Become Competitive Programmer 5 Star. So in this video I'll be solving the 23rd problem and the problem name is nearest exit. Okay, so problem says there are two exits in a bus with 100 seats. First exit is located beside seat number 1. Second exit is located beside seat number 100. Got it? So seats are arranged in a straight line from 1 to 100 with equal spacing between two adjacent seats. Got it? Okay. A passenger prefers to choose the nearest exit while leaving the bus. Determine the exit taken by passenger sitting on seat X. Got it. So they have said the first line of input will contain a single integer t denoting the number of test cases. So let us take care of the test case. Int t will take one variable t who will take care of all the test cases, and it is saying each test case contains a single integer x denoting number of seats. Seat number basically, sorry. So yeah, and for each test case output left, if passenger chooses the exit beside seat 1, otherwise right. Okay, so let's try to understand the example. And first example, there are totally 6 examples. First example is 1. So yeah, let me take you to the board. So there are first let me construct a bus basically. Don't judge me like I'm just drawing for the visualization. So let's say there are many seats, okay, and this is, let's say, seat number 1, this is 2, this is 3, this is 4, 5, up to so on till this is 100, this is 99, this is 98, this is 97, and we have many. So we have a door. Let me denote door by one line, which is on this position, and one more door we have on this position, 100 number seat. So first test case they have given x is equal to 1, which means a person is sitting on seat 1. So definitely he'll choose one seat, because if he choose this one, he'll have to travel a lot of distance. And also in question they have mentioned this distance between these two seats, okay, are equal, which means let's say this is seat 1, this is seat 2, this is seat 3. So this distance, let's say d, so this will also be d only, this distance. Let's say seat number is 1, 2, 3. So it is not like unequal distances. So all distances are equal. So definitely he'll choose to move to door number 1, which is on seat number 1. So how can we solve this? What we can do is, we know one door is at 1, other door is at 100 position. So we'll take x minus 1 will do, and then we'll take x minus 100, and we'll take absolute value of that. Absolute value is basically taking modulus value. So if you take 1 minus 1, which is 1 minus 1, it will be 0. And if you take this x is basically 1 minus 100, which will be minus 99, and its absolute value is 99. So he'll have to travel 99 distance to reach there, and in this case he'll have to travel 0. Obviously he'll choose left one. If 1 is there, then that is left seat. If 100 is there, then that is right seat. So basically we'll have to do these two. Let me try to explain you second example. Second example they've given is 50. So x is equal to 50 they have given. So basically somewhere here, let's say it is 50, person is sitting. So we need to find out now which way he will choose. So again you do x minus 1, which is basically 50 minus 1, which is basically 49. Now let's try to do for x minus 100. Okay. Or if you want to do not modulus, you can do this way also. 100 minus x, we can do basically this way. So in this way it will be always positive number only. So you can do this also. So 100 minus x is 50, which is 50. So obviously 49 is smaller than 50. So he'll choose again left seat, because it is x minus 1. Now let's try to look into some more examples. We have 100, we have 30, 51. X is equal to 100, 30, 51. This is third case. this is 4, this is 5th. So let's take this case. When x is 100, so if you do x minus 1, this will give you 100 minus 1, which is 99. So if you want to choose this one, you will have to travel 99 distance. But if you take 100 minus x, that is 100 minus 100, which is basically 0. So obviously this distance is smaller. So in this case, he will choose the right seat, right window. So person is sitting here, he will choose to move out of this window. I mean, sorry, this door. Now let's try to understand when x is 30. When x is 30, so somewhere he is here, let's say. So if you do x minus 30, that will be 100, sorry, x minus 1. So if you do x minus 1, that will be 30 minus 1, that will be 29. And if you do 100 minus 30, that will be, you will have to do here 100 minus x. So it will be 100 minus 30, it will be 70. Obviously this is smaller, so the person sitting at this seat, he'll choose to prefer door number 1. So I think pretty much you got the problem statement. So let's try to code it up. We'll take one left variable, we'll take left distance. Okay, left distance, this will be as you saw x minus 1 it will be, and int right distance we'll see, that will be 100 minus x. Okay, we'll have to check if left distance is less than right distance, that in that case person will choose left, else he will choose right. Let's try to run the code. So as you're seeing, left right, left right, right, left right, left right, right. Let's try to submit the code. Yeah, it got accepted. So this problem was pretty much like getting these two formulas basically, and then this will give the distance to the left door and to the right door. Left door is basically on seat number 1, and right door is basically on seat number 100. So whichever is having lesser distance, so obviously person will choose that door to exit. So accordingly we'll have to print it. So yeah, thank you guys for watching the video.